All right, so let's just talk through problem number 2. This is actually not that dissimilar from the module 2 um, problem where we had to do the graphing in the table. It's just now I'm giving you these specific, instead of giving you the changes, now I'm actually giving you the times. So I honestly think doing the table is kind of the easiest way to help organizing the information. So for example, on here on part A, I might just go ahead and draw a table in here. So let's call this T for time and H. So I'll label that up here too so that it's more clearly defined. And we know that at 2.2 minutes, the height is 15.12 centimeters. And we're now asked to find the height at 4.3 minutes. So our first step is to find the change in time. So from 4.3 or 2.2 to 4.3 minutes, I would just subtract 4.3 minus 2.2, and I'm going to get a change in time of 2.1 minutes. So then we need to find that corresponding change in height. So my first step here, if I want to record my steps there. My second step is I want to find my corresponding change in height, and I'm going to do that by using my constant rate of change. I know for every minute that elapses, the height increases by 4.6 centimeters. So if 2.1 minutes elapses, my height is going to increase by 4.6 times 2.1, which is 9.66 centimeters. Sorry, I'll finish my labeling. So that is my change in height. So that means to go from here to here, I'm going to go up by 9.66 centimeters. And so finally, my last step to find my height, I'm going to do 15.12 plus that 9.66 because my height started at the 15.12 centimeters, well, the one I knew, and it went up by 9.66, and that's what leads us to 24.78 centimeters. So it equals 24.78. Sorry, my handwriting is a little messy today. If I wanted to show that on my graph, right, it's just very similar. So here I could say this is my change in time of 2.1. We don't have units on our scales on our axes, so we're just kind of making it up. In that 2.1 minutes, the height's going to go up by equals what, 9.66 centimeters we said. And so that gives us this new point of at 4.3 minutes, the height is 24.78 centimeters. So that's kind of like that's part A. Part B, C, and D are going to be pretty similar. I'm just going to kind of do part B pretty quickly. I'm just going to start here. Now, one point I do want to make is that you can use the constant rate of change from any point. So theoretically, if you wanted to, you could make your table and say, well, I'm going to go from that 4.3. So I know at 4.3 minutes now, my height is 24.78, and now I want to find the height at 6.6. You could do that using the constant rate of change, and that is, if you do it correctly, you will get the right answer every time. I'm going to go back to my reference point of 2.2 minutes and 15.12 centimeters, just because that is going to actually help me later on when I'm looking ahead. I know where I'm going with question 3 and 4. So we'll do this. So my first step, so to find my change in time, right, we do that 6.6 minus 2.2, and we get 4.4 minutes. Right, then I need to find my corresponding change in height. I don't really have a ton of space here. And I do that by doing my constant rate of change times my change in time, and that's going to get me my change in height of 20.24 centimeters. And that's what this is, so plus 20.24. And then I get my new height by taking my reference height and adding the 20.24. And that is going to get us a height of 35.36 centimeters. So equals 35.36, and the units on that are centimeters. And so again, if I wanted to, I should have done different colors. I didn't. I guess I'll do it now for this part. So let's pretend like this is all blue. I could go out here and say, well, I could have done this, and I'm going to end up with something like this here, where this is like my change in time of 4.4 centimeters, or 4.4 minutes. This is my change in height of 20.24 centimeters, and then that gets me my new point at, what is it, 6.6 minutes, comma, 35.36. Oops, 36. Okay, that's kind of what that is. So I could continue on. Now notice here that this 0.8 minutes is before my reference time. So I'm going to go ahead and make my table again. This time I'm going to put the 0.8 first because we tend to think of tables as the input always increasing. You don't have to, but that's how we tend to think. So in this case, I'm not going forward in time, I'm going backward in time. So when I do my change in time, I'm going to use this same process, So here we did 4.3 minus 2.2, 6.6 minus 2.2. Here I'm going to do 0.8 minus 2.2, and I'm going to get negative 1.4. And so I'm going to get a negative change because I'm going back in time. So here I'm decreasing by 1.4 minutes. And that means to find my change in height, I still do the croc times my change in time, because still for every minute earlier, my height would now decrease 4.6 centimeters. And when I do that, I get negative 6.44. So 1.4 minutes earlier, my height is actually going to decrease by 6.44 centimeters, which means my new height, it's really, I'm adding a negative if I want to be technical about it. That is going to get me, sorry, I'm out of space, 8.68. So 8.68 centimeters. And so in this case, we're actually now like decreasing. So my change in time is a negative 1.4, and we are going to decrease. So our change in height is going to be negative 6.44. And so we get this new point here. And that point is going to be at 0.8 minutes. My height is 8.68. All right, and then finally I can do this one last time. That same idea here. I'm earlier in time, so I'm going to put that there. And I have my 2.2. I have my 15.12. And again, as a reminder, you could pick a different point, but I'm picking the same reference point just because I know it will be helpful. So my first step, find my change in time. So 1.5 minus 2.2 is negative 0.7 minutes. So this is negative 0.7. My corresponding change in height is my croc times my change in time. I'm going to get negative 3.22 centimeters. So here I'm going to be decreasing by 3.22 centimeters. And then my new height is going to be my reference height, technically plus, but I know we tend to think of it as just minus the 3.22, and that's going to get me here. So this is my 11.9. I am out of room on my graph, so I'm not going to do that on my graph, but now at least you can see the idea of, notice that process. So if I do this, so that first step is finding my change in time, second step, change in height, third step, my height. That is true every single time. And if you take a look, you'll even see the steps that we take are the same every time. So that will help us generalize this process, which you guys are asked to do in question number 3 and 4.